In this section, we're going to talk about how to factor trinomials that are of the form x squared plus bx plus c. And we're going to also go over how to factor out the GCF. And we'll even do some problems where we use both techniques together. Now, the first important thing to realize is that factoring is the reverse of multiplying. And let me show you what I mean by that. Let's say we had the multiplication problem that was, let's say, x plus 2 in parentheses times x plus 4. Now we've learned how to multiply that, and remember we have to do the first, the outers, the inners, and the last, which we sometimes call FOIL, to multiply those together. So when we do that, we'd have x times x would be x squared, and then the outers would be x times 4, so 4x, and then the inners would be 2 times x, so 2x, and then the last 2 times 4 would be 8. And then we always can combine those inners and outers together because they're like terms. And when we do that, we end up with x squared plus 6x plus 8. And that process is called multiplying. Now, when we're factoring, we're going backwards. So in a factoring problem, we would start with this trinomial, and we want to work back to create this FOIL multiplication problem. And the process of taking the trinomial and rewriting it as a multiplication problem is called factoring. And that's what we're going to be learning how to do. So in order to do this factoring, we have to see how that works. Now notice that there's a couple things that are really important to notice here. Number one, this last term in the trinomial, the positive 8, is the product or the multiplication of the two numbers in the multiplication problem. So 2 times 4 equals 8. Okay, so that's one thing to notice. And that's always going to be true in this kind of factoring. And the other thing to notice is that this middle number, the plus 6, the coefficient in front of the x, the 6, is the sum of the 2 and the 4. So 2 plus 4 equals 6. And the reason for that is because they, as we pointed out up here, end up being the like terms that can be combined. So when we go backwards, we just have to try to find the two numbers that would multiply out to this last number and add up to the middle number. So let's look at this example. Let's say we had x squared plus 7x plus 12, and we wanted to factor that. So the first thing we do is we know it's going to factor into a FOIL multiplication problem. So we could put two sets of parentheses in like this. And next, we know there's going to be an x starting out in each one. So now we just have to find two numbers that multiply out to equal 12. And those same two numbers have to add up to 7. Alright, so it's kind of like solving a little puzzle. Sometimes I write it down this way. I'm looking for two numbers, so I'm putting in blank spaces that multiply out to equal 12. And those same two numbers have to add up to equal 7. And usually if you think about it, you can figure out what those two numbers are, but sometimes it might be a little harder than others. But in this case, it's pretty clear that the numbers are 3 and 4. Because 3 times 4 is 12 and 3 plus 4 is 7. So when we'll just put the plus, and since both those numbers are positive 3 and positive 4, we put a plus sign in front of each one. So it would be plus 3 and plus 4. And it doesn't really matter which one you put first and which one you put second, because the important thing is that one set of parentheses is x plus 3 and the other set of parentheses has x plus 4. But it doesn't matter which set of parentheses come first. So that would be the factored form. Okay, let's look at another example. This time we have x squared minus 12x plus 35. So this is the same type of problem. It is important to notice today that we're talking about trinomials that have a leading coefficient of 1. That means the number in front of the x squared is a 1. And if there's another number in front of the x squared, we're going to have to actually do this problem a different way, and we'll learn that in the next section. But for today, we're focusing on problems that start out with a 1x squared, meaning there isn't any number written in front of that x squared. So in this case, we know we're always going to be able to factor that into a FOIL multiplication problem. So we'll just go ahead and put our parentheses in there. We know we're going to have an x starting out in each one. And then we have to find ourselves two numbers that multiply out to this last number in the problem, so 35. And those same two numbers have to add up to equal the middle number. And this middle number is negative 12. You have to include the signs to the left of each of these numbers. So if they're negative, you have to make sure to write them down that way, and that makes a big difference. So if you think about this, what's the only way that two numbers can multiply out to a positive number and add up to a negative answer? Now, the only way two numbers can multiply together to equal a positive answer is if either they're both positive or they're both negative. And in order to add up to a negative answer, that tells you that both these numbers would have to be negative numbers. So you're looking for two negative numbers that multiply out to 35 and add up to negative 12. And hopefully after thinking about that a little bit, you can come up with that the numbers are negative 7 and negative 5. And since both these numbers are negative, when you put them into your factoring problem, you just put a minus in front of them. So it's going to be minus 7 and then minus 5. And that would be your answer. Now you can always check these answers because all you have to do is do this multiplication using FOIL. Do the firsts, the outers, the inners, and the lasts, and it should come out to equal this answer. Okay? So we always have that way of checking. Okay, the next example I'm going to do is x squared minus 3x minus 18. And we want to try to factor that. So we have the same situation. We're going to set up our parentheses and put an x in each one. And this time we need to find two numbers that multiply together to equal this last number, including that sign, so negative 18. And those same two numbers have to add up to equal this middle coefficient, so negative 3. Now, let's think this through. If two numbers are going to multiply out to equal a negative answer, that tells you right there that one of them has to be positive and the other one has to be negative. So you're looking for one positive number and one negative number in this kind of a problem. And when you add those two numbers together, you want to end up with negative 3. Now that's really telling you that the negative number has to be the bigger number, because when you add a positive and a negative, the sign of the larger number carries into the answer. So after thinking this through, the numbers are negative 6 and positive 3. So negative 6 times 3 is negative 18, and negative 6 plus 3 equals negative 3. Okay, so those are the two numbers. So it's going to be x minus 6 and x plus 3. Okay, now let's look at x squared plus 6x minus 8. So I'm going to try to do the same thing here. So we'll set this up the same as before. Now this time we're looking for two numbers that multiply out to equal negative 8. And those same two numbers have to add up to equal a positive 6. Now, again, if they multiply together to equal a negative answer, that tells you right there that you're looking for one positive number and one negative number. So the possibilities could be like a positive 4 and a negative 2, but they don't add up to positive 6. Or a positive 8 and a negative 1. They don't add up to 6 either. Let's see, are there any other possibilities? 8 and 1, 2 and 4. So it doesn't look like there are any two numbers that would work there. So therefore, this expression is non-factorable. Okay? And sometimes when something is non-factorable like that, we call it prime. So the word prime in this case would mean that you can't factor it. So there's no way to do it. Just like a prime number is like a number like 7, and you can't really break it down into two different numbers other than itself and 1. So you can't write it as a multiplication problem between two different numbers. And the same thing here is you can't write this trinomial as a multiplication problem either. So it's called prime. All right, next I'd like to look at an example that has two variables. Okay, so notice this one's a little different. It still starts out with an x squared, but the middle term has an x times y in it, and the last term has a y squared in it. So this can still be factored in a similar way. When we set up our FOIL problem, we do it the same as before. We put an x in the front of each one. But this time, because of that second variable y, and we have a y squared here, we're going to need to put a y at the end of each one. And then we'll still need to solve the same puzzle. So we're looking for two numbers that multiply out to equal 24. And those same two numbers have to add up to equal -11. And you should be able to realize that the only way two numbers can multiply out to equal a positive answer and add up to a negative answer is if they're both negative. So you're looking for two negative numbers, and the numbers are -8 and -3. So when you write it in, it's going to be a -8y and a -3y. So you see, this is almost the same as before. The only real difference is that there's a y at the end of each one of these factors. Now I'd like to go over a different kind of factoring out what's called the greatest common factor. And usually we just abbreviate that GCF, but that stands for greatest common factor. And when we factor out the greatest common factor, we're looking to see what all the terms have in common, and then we can factor that out. So for example, let's say we had 6x squared minus 18x. Now in this case, we're looking to see what's in common here. So 6 is in the first term, and 6 also divides evenly into 18, because 6 times 3 is 18. So 6 is a common factor. Also, we have an x in this second term, and we also have an x squared in the first term. But since you can only take what's in common, you can only use the x as the common factor, because really in this first term you have an x times another x, and in the second term you just have an x. And so both of them have an x in common. So the common factor would be 6x. And so you write that down, and then you put a set of parentheses after it. And then you have to fill in the parentheses. Now to fill in the parentheses, since the original expression that we're working with has two terms that are separated by that minus sign there, we're going to also have two terms inside the parentheses. So I'm going to underline two blank spaces. And the sign, or the operation of subtraction, is going to carry into the answer as well. So there's going to be a minus in between those two terms. And what we really want to do is kind of like multiply in reverse. Usually we distribute to remove parentheses, but in this case we want to fill in the blanks so that when we would distribute, we would get 6x squared minus 18x as our answer. So the question is, 6x times what? would equal 6x squared. And I think you can see the answer to that would be x. And then, similarly, 6x times what would give us 18x? And the answer would be 3. So that would be the answer. That would be the factored form. The 6x that's in front of the parentheses is the GCF, or the greatest common factor. And you see we factored that out, meaning it's in front of the parentheses. We've taken 6x out of both terms, and then we've written what's left of each of those two terms after we've already factored out the 6x. Now, one important thing to understand is when you're finding a GCF between variables, like we had x to the first and x to the second, you have to use the smallest exponent because you're taking what's in common. So we used x to the first as our common factor, which is the smaller of the two exponents. And in general, you'd always use the smallest exponent for variables when you're finding the GCF. So let's try another example. This time we have 32x cubed y plus 40x squared y to the fourth. So let's start with our numbers and try to find out what our GCF is there. We're looking for the largest number that would divide evenly into 32 and 40. And that would be 8, because 8 goes into 32 4 times, and 8 goes into 40 5 times. So 8 would be the greatest common factor. Then we'll look at the variables. Now, for the x's, we have an x cubed and an x squared. Now, we just got done talking about that we'd always have to use the smaller exponent for the GCF. So it would be x squared. And then for the y's, we have y to the first and y to the fourth. So the smaller exponent is y to the first. So 8x squared y would be the GCF. And that's what would go in front of our set of parentheses. And then remember, we're going to have however many terms you have in your original problem, which we have 2. And again, the plus sign is what separates the two terms. That's how many terms you're always going to have inside the parentheses too. And the operation of plus will carry into that answer. So we'll write that right in there. And then we just kind of want to multiply in reverse. We want to ask ourselves, 8x squared y times what would equal 32x cubed y? And so 8 times 4 would be 32, so we need a 4. And x squared times x to the first would equal x cubed. And we already have a y to the first, and we want to end up with y to the first, so we wouldn't multiply by anything more with the y's. So it would just be 4x there. And then we do the same thing for the second term. So 8 times 5 would be 40. And x squared, we already have an x squared pulled out, and we want to end up with x squared, so we wouldn't multiply by any x's at all. And then y to the first times y cubed would equal y to the fourth. And so that would be your answer. Now you should be able to check these. Just do the multiplication. Just use the distributive property to multiply that back out, and you should get the original expression as your answer. Okay, I'd like to do one more example of one of these type of problems. This one has 3 terms in the original problem. So there's 3x cubed y squared, and then 9x squared y squared, and then 21xy squared. So we have to find what's common to all 3 terms now. So let's start with the numbers. So 3, 9, and 21. So the common factor there is 3, because 3 divides into all those numbers evenly. Now for the x's, we have x cubed, x squared, and x to the first. And we know we have to use the smallest power, so it would be x to the first. And then for the y's, we have y squared, and y squared. So the highest power, the lowest power there would be y squared. So that would be our GCF, and we'll put our parentheses in. This time, since the original problem has 3 terms, we're going to need 3 terms inside the parentheses as well. And the operations the two plus signs, the plus here and the plus there, are going to carry into our answer. And we just have to do our reverse multiplying now. So, in the first blank, we already have the 3. We're going to have to multiply by x squared to bring that x up to an x cubed. And we already have the y squared, so we just need the x squared there. In the second term, we're going to need a 3, because 3 times 3 is 9. We're going to need an x, because x times x would be x squared. And we don't need any y, because we already have the y squared factored out. And then in the last term, we need a 7, because 3 times 7 is 21. We don't need any x, because we've already pulled that x out. And we don't need any y's either, because we've already got the y squared pulled out. So it would just be 7. And so that would be our factored form. Now sometimes we're going to have to use more than one factoring technique to completely factor a problem. So factoring completely requires first factoring out the GCF. Okay, so you'd always start with that step first. So look through, and if there's anything in common to all the terms, factor that out at the beginning. So assuming you've done that, you've got a GCF and then an expression inside the parentheses coming after that. Now, look at the expression that's inside the parentheses, and if possible, factor that. So, in other words, there could be 2 stages to factoring. Pulling out the GCF would always be the first stage, and then looking at seeing if you can factor again the expression that's inside the parentheses would be the second stage. So in this example, if we look for the greatest common factor first, we should notice that we have a 7, a 21, and a 14. So 7 is a common factor because 7 divides evenly into all those values. And we're going to have 3 terms in parentheses. Now the x doesn't occur in all 3 terms. See, this last term doesn't have any x at all. So x is not a common factor. So you can't include that along with the 7 as part of the GCF. The GCF is just the number 7 in this case, because in order for the variable to be in the GCF, every single term has to have the variable, and that's not true here. So if we pull the 7 out, we will be left with an x squared plus a 3x plus 2. So that takes care of this first step of factoring out the GCF. But now, that doesn't necessarily mean we're done. If possible, and sometimes it is possible and sometimes not, we want to factor the expression that's inside the parentheses. So here's the expression inside the parentheses. We want to see if we can factor that down further. So the 7 that we've pulled out is just going to carry down now. And since this is one of those trinomials that we talked about in this section, we know if it does factor, it's going to factor into a FOIL multiplication problem that starts with an x in each case. And we'd have to find 2 numbers that multiplied out to equal 2, and those same 2 numbers would have to add up to equal 3. And this one's pretty easy. It's 2 and 1, because 2 times 1 is 2 and 2 plus 1 is 3. Both of them are positive. So we'd put those in with a plus 2 and a plus 1. And that would be our final answer. So notice your final answer has that common factor out in front of everything, the 7, and then we factored the expression in parentheses into the product of those 2 binomials. So your final answer actually has 3 parts to it, or what are called 3 factors. There's the 7, there's the x plus 2, and the x plus 1. Okay, let's try another example. This time we have 4x squared minus 4x minus 80. So if you look through the numbers, you have a 4, and an 80. So the common factor would be 4, because 4 divides evenly into everything there. And as far as the variables, you have x squared, x, but this last term again has no variable. So x is not part of the common factor because it's not common to every term. So the GCF is just 4, and then we'd open up our parentheses, and we'll have x squared minus x and minus 20. All right, now we want to attempt to go farther. Now notice I say attempt because you can't always go farther, but you would want to always try. So we'll set that up the same as we did before. Notice I've just carried the 4 down, and we're trying to factor that trinomial now. So we need to find two numbers that multiply out to equal a negative 20, and those same two numbers have to add up to equal negative 1. So in this case, in order for two numbers to multiply out to a negative answer, one has to be positive and the other has to be negative. So you're looking for one of each, and they have to add up to negative 1. And the numbers that would work there would be a negative 5 and a positive 4. So you'll put them in parentheses, a minus 5 and a plus 4. And that would be your final simplified answer. Okay, so that's now in factored form. Now in this next example, if we look for a common factor, it doesn't really look like we have any because there's a 1 coefficient here and a 2 and a 35. And so there's no common factor there. And x doesn't occur in every term, so there's no variable either. But I give this example for a different reason. Whenever your first term, this leading term with the one with the highest power of x on it, which is x squared, is negative, you really want to factor out that leading coefficient. Now the leading coefficient here is actually a negative 1 because there's implied to be a 1 there. And so you want to factor out the negative 1 as a GCF. And that's because, again, the leading term, the term with the highest power of x in it, when that has a negative coefficient, which it does here, it's always a good idea to factor that coefficient out. Now when you factor a negative number out, that's going to give us an x squared here, but it's also going to change these signs as well. So that minus is going to change to a plus, 2x. And this plus right here is going to change to a minus. So it's going to be minus 35. Okay, so when you factor out a negative 1, all the signs change inside the parentheses. That's really important. So now that we've done that, we want to see if we can go further again. We always want to try that. So we'll set that up the same way we have been. And we're looking for two numbers that multiply out to equal negative 35 and that add up to equal positive 2. So it would be a positive 7 and a negative 5. So we'd put that into our answer. So plus 7 and minus 5. And in your final answer, instead of writing a negative 1 right here, you can just write a negative sign because the 1 is implied. So you'd probably see it with just a negative sign, and then the x plus 7, and then the x minus 5. It's not wrong to write the negative 1 in there, but it's also not necessary because it's implied with just a negative sign. Okay, just like to do one last example of a similar situation. Notice here we're looking for our greatest common factor first, and we see that we have a 2, a 24, and a 72. So those are all even. So we know 2 is a common factor. But again, remember the fact that that coefficient is a negative number. We're going to actually want to factor out a negative 2 as our GCF. Not just 2, but negative 2. And when we do that, we'll have x squared. And remember, this plus will change to a minus. So we'll have a minus 12x, and this minus will change to a plus, so plus 36. And then we want to see if we can go to that next step. So we'll try to factor the expression inside the parentheses. Now in order to do that, we're going to need to be able to find two numbers that multiply out to 36 and that add up to equal negative 12. And so we have to try to think, are there two numbers that multiply out to multiply out to 36, positive 36, and add up to negative 12? And it's negative 6 and another negative 6. Sometimes you can have the numbers be the same number. And so we'll have a minus 6 and then another minus 6. And you can also rewrite this answer with the negative 2. And then since these two factors ended up being the same, you have x minus 6 and then another x minus 6, you can write that as x minus 6 in parentheses squared, because it's that same factor being multiplied by itself. And that would be a little bit more condensed way of writing that answer.